Here are two questions on root mean square velocity, and we'll look at them one after the other. A gas is filled in a vessel at a certain temperature and at a pressure of 8 centimeter Hg. So some temperature and pressure is P. Pressure is 80 centimeter of Hg. At the same temperature, given that there is no change in temperature, at the same temperature, more gas is filled in the vessel so that its mass is increasing by 60%. Find the resultant pressure in the vessel. So pressure is increasing because more mass is being filled in the same volume of the gas, because the vessel is not changing. So two things are not changing. T and V are constant because it is given same temperature and the vessel is not changing. So temperature and volume are remaining constant. And we have to find the increase in the pressure of the gas. Now, one of the equations that we derived was 1 upon PV is equal to 1 upon 3 mv square. When we derived the equation of pressure of gas, we got this, where m is the mass of the gas, total mass of the gas, v is volume, and this is mean square velocity. Since the temperature is same, we have seen that when the temperature is same, the mean square velocity is going to remain constant because kinetic energy remains constant. So since the temperature is remaining constant, v square is going to remain constant. Also volume is constant. So in this equation, volume and v square are constant, and therefore I can say P is proportional to mass of the gas. And therefore, if the P mass of the gas is increasing by 60%, pressure will also increase by 60%. Very, very simple. So pressure will increase by 60%. Therefore, resultant pressure is equal to 1.6 into 80 centimeter of Hg. 1.6 because it is increasing by 60%. So 1.6 into 80 will give me 120 centimeter of Hg. So this is the new resultant pressure. The reason I did this question was not because this part is very, very simple. What is more important to learn from this question is that how mean square velocity and volume are constant and how temperature is constant. Of course, temperature is constant is given directly, but what I wanted to stress on is the relationship or the understanding that when temperature is constant, it automatically means mean square velocity is also constant. So that was the first question. Let us look at another question. At what temperature will the average velocity of oxygen molecules be sufficient so as to escape from the Earth? The escape velocity from the Earth is 11 kilometers per second, and the mass of one molecule of oxygen is this, Boltzmann constant is this. So the question we have over here is that we have Earth and there is oxygen molecules, and if it has to escape the atmosphere of the Earth, right, what should happen is that the kinetic energy of O2 molecule should be equal to, or should be greater than, or at least should be equal to the kinetic energy required for escaping the Earth's atmosphere. Now, what is the kinetic energy of an oxygen molecule? The kinetic energy of an oxygen molecule is given by, or any gas molecule is given by 3 by 2 kT. We did that when we were looking at the kinetic interpretation of temperature. We have found out that the kinetic energy for molecule is 3 by 2 kT. And this should be equal to kinetic energy required for escaping the Earth's atmosphere. That will be equal to half mv square, where v is the escape velocity and mass is the mass of one oxygen molecule. So I can use this equation and find out the temperature at which this will happen. At that particular temperature, the oxygen molecule will gain sufficient kinetic energy to escape the Earth's atmosphere. So this is the equation. 3 by 2 kT is equal to half mv square. I solve this equation, therefore I'll get 3 kT is equal to mv square. Now k is given as, so let me write those values, 3 into 1.38 into 10 raised to minus 23. Temperature is to be found out. Mass is given as 5.34 into 10 raised to minus 26 multiplied by v square. Now v is given as 11 kilometers. That would mean 11 into 10 raised to 3 meters per second square, v square. This is because it is given in kilometers. So 11 into 10 raised to 3 meters second square. Therefore, if I do this calculation, 3 into 1.38 into 10 raised to minus 23 into t is equal to 5.34, 10 raised to minus 26, 11 square would be 121, and 10 raised to 3 and 10 raised to 3, and if I do this calculation, right, I'll get the value of temperature as somewhere around 1.56 into 10 raised to 5. Okay. To save time, I'm not doing this calculation. What you can do is that 10 raised to minus 26, 10 raised to 3, so this will become, if I multiply these two terms, this and this, I'll get 10 raised to minus 23. That can be cancelled with this, and you can go ahead like that, and you'll get final temperature as this. So these were two numericals on root mean square velocity, and I just wanted to talk about these two concepts, about how this equation is used and how these two terms are constant here, how 3 by 2 kt is equal to half mv square. The math part is very, very simple. The important part is to understand the question and then arrive at these and this equation. Thank you.